In this film we're going to be looking at the practical looking for patterns and correlations. This involves studying the ecology of a habitat, and in the film we're going to consider two habitats. One, some grassland, which you can see here, an unmown region which we're zooming in on now, and then very close by, in fact right next to it, a mown area. We're going to use random sampling techniques in order to compare these two areas with each other. This is different from using a transect, which we'll consider later on in the film. So you've now seen the two areas and maybe noted some obvious by-eye differences. The job now is to compare the two areas scientifically and quantitatively. First of all, we set out a grid which is 5 meters by 5 meters, an x-axis and a y-axis. Each half meter represents a point on the axes. Random number tables give us the xy coordinates to go to. So go to 1.5 x, 2, y. You can see the ecologist now walking to 1.5 meters along on the x-axis, which he's checking, and then 2 meters up the y-axis. It can be helpful to have two people to do this. She places the quadrat bottom left hand corner at the coordinates given. Go to 4 meters on the x-axis and half a meter on the y. Similarly, she now walks to 4 meters along the x-axis. Remember that this is a 5 meter axis, so each point is represented by half a meter from the random number tables. So 4 meters is 8. And she now places the quadrat again, bottom left hand corner at the coordinates indicated. In each quadrat we would now do a detailed analysis of which plants are there and their abundance. So now go to 2 meters on the x-axis and half a meter on the y. So we're just going to show you a third one. Generally speaking, in a study such as this sort, we would do 10 quadrats, and in fact for this study that's what we have done, and those 10 quadrats as high resolution photographs are available on a separate disc for you to look at. So we would now want to discover the plants present in this, in other words a species list, and also a measure of their abundance, which we would normally do in a habitat like this by using percentage cover. Percentage cover is most accurately done using a piece of equipment called a point quadrat, which the ecologist is now setting up in our square quadrat. The point frame, as it's called, or comb, is placed at one end of the quadrat, and a needle is pushed down through each of 10 holes. All the plants touching the bottom of the needle are recorded, and then it's moved on to the second position, the third position, the fourth position, and so on, 10 positions altogether. We're now in the second position. It's difficult to see on this film, but you can see blades of grass touching the needle, and they will be recorded as being present at position 3. And just by the experimenter's foot there you can see a daisy flower, which actually the needle isn't touching, but if it was, daisy would be recorded at the next position. Once all 10 positions on the quadrat comb have been completed, the whole device is moved by 1/10 of the length of the side of the quadrat. This particular quadrat is half a meter squared, so a side is half a meter, so the comb is now being moved by 5 centimeters. And that gives us another row of 10 points to look at. So the ecologist is putting the needle down each of these 10 holes. The needle is the same thing as the point, giving it its name, the point quadrat. She's now moved it to the third, fourth, and now she's on the fifth position. That is 25 centimetres along a side of the quadrat. And there you saw her doing the first of the points and now the last. And we're now to the very last of the rows of points, the 10th one. So by now we've done 90 such points. This process takes a long time and having a little bit of difficulty getting it through the holes. But that is the 91st point, and she'll do another 9 to bring us up to 100 points in the whole quadrat. So here's the very last of those 100 points in our point quadrat. The data will now tell us the frequency of each plant on a scale of 0 to 100. In order to get percentage covers, we would use a gridded quadrat as shown here and described on your worksheets. The next job in our comparison of these two areas of grassland is to set out a similar grid and do 10 more quadrats on the other area. So this is the way that we would investigate the difference between two areas. Here we're looking at the difference in the vegetation caused by management, mainly mowing. We don't know what else has been carried out, possibly some addition of fertiliser, and the area that the experimenter is currently on is unmown and presumably unimproved. Our quadrats are positioned randomly, not systematically, and the method for positioning them randomly is to use random coordinates from a set of random number tables within a previously set out grid, not throwing the quadrats, which is both dangerous and non-random. So there's the x-axis of our second grid, and she'll now place the y-axis across the top. So it's like a giant piece of graph paper, 5 meters on each axis. So here she is going up with the second tape to place the y-axis perpendicular to the x-axis previously laid out. A little bit more difficult to do in this more rank tall vegetation, so some care is needed to get the two lines perpendicular to each other and the right length. Just making some final adjustments and our grid will be ready. Go to 0 on the x-axis and half on the y-axis. So as you can see, quadrat placement is the same. We're using another newly generated set of 20 random numbers to give us our 10 coordinates, and there's quadrat number 1. And as you can see, all of the photographs of each of these quadrats and an identification guide is available on a separate disk. We're now moving to a different kind of situation. This habitat, a rocky foreshore, this is at Robin Hood's Bay in the northeast of England, is one in which there's an environmental gradient, in this case from the landward end of the shore, where the ecologist is now, to the seaward end. We've had to wait until a time of day when the tide is out. The sea comes in and out over this area, and it can't be studied, of course, unless you've got scuba gear, until the tide has gone out. So if we waited until the tide is at least partially out, and the ecologist is now setting out a line called a transect line from the highest part of the shore that we want to study. You see she's wedged the tape into the cliff wall, a metre or so up the wall. That's because we've chosen that to be our highest place. And she's now walking down the beach towards the sea, which you can see in the background there, reeling out the tape, which in this case is 30 metres long. So she's now coming towards the end of the part of the shore which is exposed at this particular point in time. You can see the sea in the background, and the tide, in fact, whilst we were setting out this line, was still going out. So coming now to the final place on the shore which you can currently reach without getting wet feet. You can see the water there lapping around the rocks. So she's now placing the far end of the line at the furthest point that we can get at the moment from the beginning of the line. And there you can see the line stretched out across the beach, which is very wet from the tide having been recently in. Because the first part of our transect is almost vertical, I've placed a stone on the transect line there to allow us to sample that very first region. And now we can see the line from the edge of the sea, and we can see the shore that it's crossing. And already I think you'll be able to see that there are differences as we move along the shore. Very much more seaweed down where we are now. And there's the end of the line at the moment. So now we're doing the first sample, and what happens here is that the quadrat is placed against the line in the 0 to half a metre region. Here it is now placed against the line at 2 metres. We've missed out 1 because there isn't much of a change. So our next position, which we'd need to carefully note, is 2 metres along the line. Now you can see it, and then we would look more carefully in the quadrat and estimate percentage covers of organisms living there. So we've now done the 2 metre quadrat and the half metre quadrat. We've now moved down to 4 metres, as you can see on the transect line. Quadrat's been placed. We do our estimate of percentage covers. There isn't very much in this one, and note down all the results that we get. And there we are back up to the starting point. We've now moved down to the next position that we've decided to take. If we don't take regular positions, we call it an interrupted belt transect. So now we've gone from 4 metres and decided to do our next quadrat estimate at 9 metres. Basically because there isn't much change between 4 and 9. We have a closer look in the quadrat on this occasion. A little bit of green algae there which we'd have to estimate percentage cover of. And then when it comes to animals, she's currently pointing at a limpet. We would estimate their abundance by doing a simple count. We've now moved on another metre because things are changing quite rapidly now. So we're at the 10 metre point. We look in the 10 metre quadrat. You can see there clearly 2 limpets. There's also some seaweed to the left. Here we are at the next position we've decided to look at, which is the 11th metre from our starting point. You're not going to get a chance to actually do counts in these quadrats, but there is a separate disc with more photographs on it. But you can see here seaweed and bare rock need to be recorded in that quadrat. We've now moved on to the next one, and we just keep doing this until we come to the end of the shore. We're going metre by metre now because things are getting more interesting. You can see there around the quadrat lots of barnacles, seaweed occupying, I would say, at least half the area inside the quadrat. For a proper study, we would be identifying the seaweed species. And there we are looking back now from 12 metres back up to where we started, a metre up the cliff face. We've now moved on to our next quadrat position, 13 metres. A couple of limpets there outside the quadrat, so they wouldn't be recorded. But lots of barnacles in the quadrat, We might decide to do those by percentage cover, or we might count them. This would be something which could be thought about and discussed in the field. We now see the shore going from a fairly shallow sloping ledge to a sudden drop onto another ledge. And this is the 14th metre along our transect line. You can see there 14 metres being pointed out to you. And we'll probably get quite significant changes in the organisms, because effectively we're dropping so that this area would be a metre below the sea when other areas weren't covered. We've now moved on to the 15th metre. Again, we would do estimates of percentage cover. There's a brown seaweed, there's a green, and also we've got the edge of a rock pool in this quadrat. In our field notes, we would simply note that down, and it might then be used to explain differences when we plotted our data. Here we are now at the 16th metre. Remember, this is a 30 metre tape, so if we've reeled out the whole tape, we're halfway. This is mainly barnacles with a little bit of seaweed. We've now moved along the line again. And we're now looking at the 19th metre along our line. Two sorts of seaweed and a few barnacles in this one. And here we are at the 20th metre, so 2/3 of the way along the length of the tape. A lot of seaweed in this quadrat. Percentage cover is approaching 100%. Now the percentage cover of the seaweed's gone down a little bit at the 21st metre. Again, we'd need to estimate percentage covers or frequencies or abundances using grids, point quadrats, or counting. Here we are now at the next point. It's just obscured by the quadrat there. I think we'll get it clearly shown to us in a moment. So this is the 22nd metre from the start of the transect line. And this time we've got seaweed, which is mainly a species called Fucus spiralis, covering well over half of the quadrat. And we're now having another look back up the shore to see where we've come from and see what the shore looks like. And we can see it's patches of seaweed and bare rock with barnacles and limpets scattered around onto mainly bare rock as we get further away from the sea. And there we are back at the origin, right at the far end. Here we are now then to the 24th quadrat along the line. You can see mainly covered in seaweed here. And here we are at the very end of the line which she originally set out, which you'll remember she was paddling in seawater. This is the 26th metre, 4 metres from the end of the length of the tape, but this is as far as she could get 20 minutes or so ago when we started doing this. First of all, that you can see that the quadrat is entirely covered in seaweed at this point. But now the tide's gone out further and she's able to take the line out further. Now we happen to have only a 30 metre line, so at this point we'd have to stop because our tape has run out. More on that in a minute. But it may have occurred to you there may be things under the seaweed. So in fact at each quadrat the ecologist would have to search underneath the seaweed, and here we are straight away finding there a periwinkle, there's a limpet, there's another limpet and another, pulling more seaweed away, and we see a lot of encrusting algae called lithothamnion all over the rock surface. Another limpet there. So a much more careful study would have to be done than we've necessarily shown for each quadrat in this film. We've now moved down to an obscured position which we see is 28 metres. So we're 2 metres from the ultimate end of the tape that we've got. And at 28 metres again we've got pretty much 100% coverage with seaweed, but remember we'd really be searching under this seaweed to record all the other things. And here we are at the very end of the tape that we've got with us. We're now at 30 metres and we can see all sorts of marine creatures in here. There's a limpet on a loose piece of rock. Got another periwinkle there. We've also got, you can see one by the ecologist's arm, and she's picked one up. This is a dog whelk, a very common predator of barnacles on rocky shores. Whelks are recognised by the fact that they have a groove underneath the shell, which you can see there by the ecologist's index finger. She's pointing out along the rock surface there a number of limpets and dog whelks, and just there outside the quadrat are two sea anemones, very large fat sea anemones sat underneath the rock, and we'd no doubt find these in quadrats down at this level. If we wanted to carry on from this position, of course, we could take the tape, wait till the tide went out a bit further and make naught at our present 30 and go another 30 metres. But I'm sure by now you've got the idea. There we are, finding more things under the seaweed as we search more and more carefully. This kind of study could take half a day. Obviously can only be done when the tide's out. There we've got some red seaweed on the right and a rough periwinkle on the left. And there we can see the rest of the shore still covered in the sea, but at this point the tide still had about another 2 hours to go out to low tide. And we can see the sorts of things that we would be seeing once we get further down. Lots of limpets and barnacles, together with lots of seaweed which we can see floating on the surface. So we'll have a look back now at the transect that we've done. So 30 metres long. Potentially it could be 60 half-metre quadrats, but we've done about 12. And there we are, right the way back to our origin point at 0 metres, back up on the cliff foot. The environmental gradient is caused by changes in environmental conditions, and in order to think about that we need to make a shore profile. This piece of equipment is a clinometer which can tell us angle of slope. Here it's 23 degrees. In order to get a proper angle of slope, 2 people are needed. One stands at the highest point we want to measure, which we're going to take as the rock at the bottom of our first line, because that's virtually vertical, of our first metre. And the second person puts their ranging pole, which is what those red and white things are called, at the next position. The second person then lines up a position on their ranging pole with the same position on the one that's higher or lower than them, and that allows them to read the angle between those 2 poles, and the angle between any point on the poles will be the same as the angle at the bottom of the poles. So the 2 ecologists are finally in position and the clinometer reading is being taken, and we're homing in on it there. You can see the reading on this occasion. It says read here is about 21 degrees. So it's a 21 degree slope downwards from the first point to the second point. So the second ecologist now becomes the first ecologist, whilst the first ecologist goes and collects her ranging pole to move it to our third position, and she becomes the second person who uses the clinometer to find the angle. So she's taking the clinometer and moving along to our third position. Again, you have to take decisions about where these positions are going to be. We've decided it's a gentle, even slope from our second to our third position, where she's now standing, so we just need the angle of that slope. We think it's slightly upwards. We're at 13 metres, you can see on the line there, and our second position was 2 metres. So she's now taking the angle from the third position to the second position. And here we are showing us the reading, which is coming out this time at just around about 0. So in actual fact, it's just about flat. Here we are further down on the shore, doing the same thing again. In order to be able to put this data onto graph paper and look at the shore profile, we need to know the distance between the two ranging poles, and we need to know the angle between the two ranging poles. So all those results will need to be written down as we get them in the field. So here we are ready to do another measurement lower down the shore. So we'd note the position of the ranging pole and the position of the other ranging pole, now taking the angle between the two. You can see the clinometer is slightly angled upwards, so she's slightly down from the previous ranging pole that she's looking at. You can see there that the reading is about 6 degrees. So it's a 6-degree slope downwards. Once we have all the data for the percentage cover or frequency or number of organisms in each of our quadrats, they then need to be plotted in some way. And the most common way that's used for rocky shore transects is to produce what's called a kite diagram. Here's a kite diagram of a different beach than the one that you've seen in the film. This one is actually from a place called Bembridge on the Isle of Wight, which is just off the south coast of England. And you can see on the quadrat here organisms like the top one in red, very abundant at the top of the shore and then completely gone by the time we get to the bottom. Whereas if we look at the one towards the bottom of the kite diagram in bright blue, none at the top and then very abundant at the bottom. This tells us how much of what occurs where. The next question that the ecologist would ask would be why. A whole range of factors, including light intensity, temperature, humidity, salinity, etc., could account for the differences that we find. The shore profile that we measured and can produce would help us to think about this, but in the end we can only really get good answers to the question, why does an organism live where it lives and why doesn't it live in other places, is by experiment. You can read and find out more about this on the website that you'll be directed to at the end of this film. The address is www.takeyouvirtuallyeverywhere.com, all as one word. But you can see this at the end of the film and on the worksheet which goes with this film.